Hi, and welcome back to another video of Math Skills to Ace Chemistry for Introductory Chem. So in this video, what we're going to be looking at is what is scientific notation. And if you watched my last video on rounding, you might have saw that at the very end that it was a different number format. And the whole idea about this is it's an easier way to do a lot of mathematical calculations. It helps simplify them, and that's something that we'll see in the future. So in this video, what is scientific notation? Well, it helps almost make simpler really, really big numbers or really tiny numbers. So that way they're a little bit more palatable. They're a little easier to plug into your calculator and to solve them and to use them in different calculations. So, well, what is this? What do you mean by really big numbers? Well, let me tell you. So what if I told you if we had the following number, which is 602 with a lot of zeros, probably bigger than any number you've ever seen before? Well, this is Avogadro's number, which is a very common number that's used to count how many atoms or molecules. And when you see that, that's in its standard notation. And probably the thing that you see is what came to your mind is, oh my god, is that big? That is huge. Do we actually have to use it? Do I have to know that for class? Well, that's what scientific notation is for. It's to help make this a little easier to handle, so that way we can almost minimize what this is. Now, what it is it's counting the number of places that you're moving the decimal. So there's a couple little simple little rules that we are going to be doing here. So let's take a look at this and try to understand. The whole idea here is that the key is to write numbers as a factor of 10. So let's start small and then we'll go back up to that number before. So if I have the number 500, okay, well, 500. How can you write that in, let's say, factors of 10? So how would you multiply to get to that number? If I could do 10 times 10 times 5, that would get you to 500. So think about it that way. If I take 5 times 10, right, which would be 50, and if I times that by 10 again, well, that would be equivalent to 500. That's the same thing. Now, do I have to write all these numbers out times 10 times 10? No, this is what exponents are for, or powers. So if we want to show that, well, we can write different powers. So if I say, oh, 5 times 10, and being that there are 2 of those different 10s, we can say 5 times 10 to the second power. So we can use exponents to help say how many places we jumped or how much did we move. So another way you can show this is that 10 times 10, well, what is that? That's 100, right? So it's the same thing as saying 5 times 100. So in the end, how did we get to here, which is scientific notation? Let's write that down for ourselves. So that's our scientific notation, trying to block it with me. Now, the whole idea here is that all we did was, if I kind of like go to that 500 number, we'll just write in the middle, is if we imagine that we have a decimal here, right? It's not shown, but there is a position for it, which is right over next to the last zero. And the whole idea here is that we move that decimal place 2 times, right? We went 1, 2 jumps, which represents how many factors of 10 that you needed here, right? So what that told you is that, oh, when you wrote that down, you had your 5 times 10 to the second power. So it helps you see how many spots you are jumping. And that's how we write scientific notation. So instead of us doing a 5, we're doing times 10 to the 2. So one of the simple rules here when it comes to scientific notation is that when we are writing this down, the first number, so we had 5 times 10 to the second power. So 5 in this case is represented by A. That must be between 1 and 10. So 1 through 9, right? So between. So that has to be in a very simple number, right? You can count 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really easy to do. And if you multiply, let's say 5 times 5 or 4 times 3, like those are things you have been drilled in your head since like 4th or 5th grade. It's something that's always been there. Now the 10 to the b part, well, that's the power, the exponential part. That tells you how big something is or how small, right? So in the current time, that's telling you the bigness of something. So we're counting how many factors of 10 or how many jumps are we doing. So if I go back up to what I had before, we can calculate how many jumps did we have, right? So if I go through this and we see that, all right, well, we go 1, 2, 3. Oop. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So when we write this, we only write the significant digits, right? So we have the 6.02. That's your sandwich non-zeros, right? The rest are all trailing. There's no decimal. And then we write times 10 to the 23, and that's what it shows. So it shows your significant values, and it helps you simplify a giant number such as this. And that's the best part, is that it shows significant values and it makes it easier to look at. So what this is this is a number that tells you how many molecules or atoms there are in a given sample. So if you had like let's say like a small glass of water, like maybe a shot glass, and you had half of it filled with water, this would be how many molecules of water there would be in that little shot glass. It was a fun example. So that's the idea about it. So let's try to do some do some different examples. So if I kind of go down here and I ask you, all right, well, let's try one and put it in scientific notation. So if I have 1 million, we'll put 1,004,700 00, and I asked you to put it into scientific notation. Well, how exactly would you do that? Now, the big idea here is that you're moving that hypothetical decimal point to make the first number between 1 and 10. So if we see that, well, right here would be between 1 and 10. So the whole idea here is that we're going to continue to move that point. So it'll be 1, 2, 3. Move it again, 4, 5, 6. So we're just kind of bunny hopping along the way. 7, 8, 9. So we move that 9 spaces. So this would be 1 point. Now, which digits are significant? Well, that's going to go to your last non-zero value, which is our 7 there. So this would be 0, 0, 4, 7 times 10 to the 9th power. So not only does it show only your significant values, but it also helps make it a little bit easier to look at and to work with. So if I kind of let's say I expanded on this question and I asked you, why don't you round the following to 3 sig figs in scientific notation? So the one that we just did above, let's round it. So if I said round it to 3 sig figs, how could you do that? Well, we could count 1, 2, 3. We're going to look over just like how we did in a rounding video. And we can see, well, to the right of that last 0 is a 4. So we round down. So what this number would turn out to be is 1.00 times 10 to the 9th in the scientific notation. And if we want to put that back to standard form, we could, where we just move that decimal place back 9 spaces to help show what the big number originally was. So as you can see, it gets rounded and you kind of lose some of the digits along the way, but it helps it be in either standard form or scientific notation form as you're going through these. And the key note here is when you're working with these is that positive number in the exponent, so being that this is a positive 9, for example, what that is showing is that, oh, that this is a very, very big number. If I look at this example down here, well, we can see we move it 1, 2, 3, 4, 5, 6. This would be 10 to the 6. That 6 is positive. We had to move that decimal place left. So that's letting you know it's a positive exponent. If you have to move it left, going to scientific notation form, then it is a positive exponent. It's a big number. It's very, very large. So keep that in mind. Now, what about small numbers? We talked about big. Well, what about tiny? So a lot of times in chemistry, we're talking about tiny amounts, right? We're talking about atoms and molecules and all these little itty bitty things that you can't see. So if, in this case, if you have your decimal number and you're moving the decimal to the right, I like know how my pet's going the wrong way, but you're moving it to the right, it's a negative exponent. So if we do a couple examples here, so if I have 0.001, so once again, our A value, as we showed it, it has to be between 1 and 10. So we're going to move that decimal place 1, 2, 3 spots. And we can see that we have 1. And being that there's only one significant value here, this would be 1 times 10. And being that you moved it to the right, it's going to be a negative exponent. So it's going to be 10 to the negative 3. And that's going to be your final value for that answer. We do the next one where we have 0.0324. Same idea here. We move that over 2 times to show that, okay, it's going to go after your first non-zero number. In this case, will be 3.24 times 10 to the negative 2, because we had to move that over 2 times. And because we had to move it to the right-hand side, that shows you that it's a tiny number. So it gets that negative exponent here because it's small. So this would be our final value for that answer. Now, just to kind of, what's the final summary when it comes to scientific notation? Well, if we're going from standard form, so seeing really big numbers or really small decimals, to scientific notation, you move the decimal until it's between 1 and 10. Keyword between, right? It has to be a single digit in the front of scientific notation. The new number, let's call it A, should always show the correct number of sig figs. And that's the important thing, is we are always showing significant figures, especially if you're someone that has to do general chemistry 1, 2, and maybe your science major. You're always going to be doing sig figs throughout your entire career. Even if you're working as a health professional, you need to show the correct number of sig figs when you're giving out medicines and doses and all those kinds of things as well. It's very important. Now, if you write that times 10 to the b part, or the exponent, that counts how many places you move the decimal. So if you moved it left, then it's a positive value. If you moved it right, then it's a negative value. Sometimes you'll have to convert it the other way, meaning that you'll be given a scientific notation value and you have to convert it to standard form or just a regular number. Meaning that this also applies to the backwards direction or the opposite world. So keep in mind that that trend that I've been showing you this whole time about left and right, it's not going to necessarily apply. If you see a positive exponent, that means that you're moving that decimal to the right-hand side. If you see a negative, you're going to be moving it to the left. So keep in mind of bigness or smallness when you are coming across all these different values. Let's do one example of the backwards. So let's say if I had 6.32 times 10 to the negative 6. Well, this is a negative value. So that tells you the decimal place is going to be moving to the left-hand side, right? So it's going to be moving left. So, or sorry, I'm still pointing the wrong way. So it's going to be moving left, right? So as we're moving left, what that tells you is that we're going to be going 1, 2, 3, and being there's 6 here, right? So we see a 6, 4, 5, 6 places. So as we're filling in all those numbers, those are all going to be zeros that are going to be added in front of this as that decimal place moves. So we can count that, right? We have 1, 2, 3, 4, 5 zeros that will be out front. So this will be 0.000000632 would be your number here. So it's showing you, just to kind of even show you, because I misspoke that I said there would be 5 zeros out front. That's after the decimal. So just to kind of show that, right? It was 1, 2, 3, 4, 5, Oh, 6. Oh, did I actually miscount? 1, 2, 3, 4, 5, 6. Oh, I did right. Okay. Yeah, sorry, I miscounted. So it would be 6 places that moved. So when we are going through doing these different scientific notation values, it's going to be showing this number sig figs. There'll be rounding involved when you are looking at all these different values. Okay. I hope this video helped you, and please stay tuned. There'll be more to come in soon on YouTube here. Please like and subscribe. Let me know how it all was, and let me know if there's anything I can do to help you pass chemistry. This has been my Math Skills to Ace Chemistry, and look forward to seeing you soon. All right, bye now.